So in this segment, we're going to be looking at a basic introduction to combinational circuits and how a combinational circuit is designed. To start with, what is a combinational circuit? In simple terms, it is just some combination of logic gates, your basic logic gates like AND, OR, XOR, NOR, NAND, NOT, etc. In such a way that you give n inputs. Inputs are binary variables. So if I say you have two inputs x and y, they can take the values 0 or 1. Those are the possible values. So x can take 0 or 1 and y can take 0 or 1. So in that form, we give the circuit n inputs. These inputs pass through the circuitry, the combinations of logic gates, and come out as m outputs, where n may or may not be equal to m. And these n inputs can be of 2 power n possible combinations. For example, if you take 3 inputs, if I say we have 3 inputs x, y and z, the combinations possible are 0, 0, 0, 0, 0, 1 and so on up to 1, 1, 1, which are 2 raised to 3, that is 8 combinations. Similarly, if I say I have 2 inputs x and y, then the possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1, which is 2 raised to 2, which is 4 combinations, and so on. So when I say I have an n input combinational circuit, then I mean I have 2 power n possible input combinations, and for each of these combinations the circuit produces one output, m outputs. For each combination it produces m outputs. So this is the basic definition of a combinational circuit. Now when we are asked to design a combinational circuit, how do we go about? We start by listing the objective. By objective, what I mean is what is given to the circuit and what is it supposed to produce. For example, if you take a half adder, you will be given 2 input bits, x and y or a and b or whatever, and you have to produce 2 output bits, where one of them is the sum of these 2 inputs and the other is the carry. So like this you list out the objective for any combinational circuit. The next step, you identify the number of inputs and outputs. For example, in this case, there are 2 inputs and 2 outputs. Now, you draw a truth table for all the 2 power n input combinations and their respective outputs. So, for example, here let's say I have 2 input bits x and y. The combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So, what we do is, we draw a truth table with x, y, sum and carry. And for each of the above mentioned combinations of x and y, we list out what the sum and carry will be. Now using this truth table, we find the relation between the inputs and outputs. So we'll be deriving this soon, but if you try this out for the half adder example, when you have x, y, sum and carry, you will get the expression sum equals x XOR y and carry equals x and y. So how do we derive this? We can use K-map or Quine-McCluskey method or any other method that you are familiar with to derive an expression from a truth table. Finally, once you have the expression, you just have to draw the logic diagram. So a quick overview. A combinational circuit is basically some connection of logic gates which takes n inputs and provides m outputs. The n inputs can make 2 power n possible combinations, and for each of these combinations there is a unique output. Now how do we design a circuit? We first list the objective, identify the number of inputs and outputs, then we list all the input combinations, the respective outputs, and we draw a truth table. Using this table, we find out the relationship between the inputs and the output, and we draw the logic diagram. So this is the basic idea behind the construction of a combinational circuit.